We've never been able to actually journey to the center of the Earth to see what it's like, but thanks to an incredibly innovative experiment, we may not have to actually go there to understand the deepest inner workings of our planet. So far, we've mostly explored Earth's interior using seismic measurements, basically measuring vibrations that pass through the Earth to tell us more about what's going on in there. Thanks to research like this, we know that the Earth has an innermost, super dense solid core surrounded by a less dense liquid outer core. But an exciting new experiment tells us details about the Earth's core that we've never had access to before. And this research uses something called a diamond anvil cell to achieve its results. As strange as it sounds, a diamond anvil cell is literally two rather glamorous-looking diamonds pressed together to create a tremendous amount of pressure. Like, this science is truly blinged out. By putting a sample of a material in a diamond anvil cell, we can see how it behaves under these extreme pressures, which is exactly what these researchers did with liquid iron. Iron is not only the sixth most abundant element in the universe, it's also thought to make up a large part of the core of our own planet and the cores of Mercury and Mars. So understanding how iron behaves under extreme circumstances is essential to understanding the inner workings of our planet, and even how Earth formed in the first place and how it's evolved since. The tricky part, though, is creating those extreme conditions for extended periods of time. So far, it's been pretty tough to put liquid iron under super high pressures for longer than a few microseconds. That's not really long enough for us to be confident about drawing hard conclusions on a material's behavior. But the diamond anvil cell technique has given us just that, a long and extreme enough look at iron samples to tell us details we've never had before. This team was able to smoosh a minuscule drop of iron down to 116 gigapascals. That's over 1,000,000 times greater than the pressure we feel here at Earth's surface. And they heated it with an infrared laser to 4,350 Kelvin. That's around 15 to 16 times hotter than average room temperature. Those are temperatures and pressures really close to what you find at the Earth's core, and they're conditions we've never reached before with diamond anvil cells. The researchers held it at those conditions long enough to use a highly focused X-ray source to essentially take a picture of what was going on inside that droplet of liquid iron. These conditions replicate what we think iron would be experiencing in Earth's outer core. So this experiment allowed us to probe what the composition of that liquid iron core might be like. But when the researchers compared the measurements they took of this drop of pure liquid iron at these conditions and compared it to the seismic data we actually have of Earth's core, they didn't match up. The experimental iron droplet was about 8% more dense than the measurements we currently have for Earth's core, meaning that there are probably other, lighter elements hanging out in Earth's core that we currently haven't identified. I had no idea that so much was unknown about what's going on inside our planet. That is just totally wild to me. Now, while I was able to tell you the setup and process for this experiment in pretty much less than 30 seconds, it took this team over 2 decades to perfect this experimental setup and get it to the place where it could give us these results. Talk about pressure in more ways than one, man. In fact, teams all over the world have been developing diamond anvil cell experiments to give us more answers about our planet, like one from 2019 that explored iron alloys under pressure to better understand the behavior of Earth's magnetic field. But now that this latest research has successfully achieved these record-breaking extreme conditions with iron, they and other teams around the world could adapt this technique to explore other materials in the same way. This could help us get a better picture of the way Earth's interior has evolved and may continue to evolve over time, and maybe further work like this will finally help us nail down what those still unidentified mystery materials inside the Earth really are. If you want more on the cool and surprising stuff happening below Earth's crust, check out this video here and keep coming back to Seeker for all of your wave-making news. If you have other high-pressure experiments you want us to cover, leave it for us in the comments down below. And as always, thanks so much for watching. I'll see you next time.